Greetings and welcome to R Squared Scientific. We're here today to introduce our new query cracking program, Quacker. So let's take a look. So when you send a query to SQL Server, what it does is it looks at the query and it creates what's called an execution plan, and it breaks it down into little tiny steps. So what Quacker does is it examines each of those steps and see how long they take, what resources are being used, so you can figure out exactly where in your query you have a problem or where it's just taking too long. It makes it easy to look at all the information in one place. So let's begin with that. Okay, let's start with a little tour of Quacker. This area here is where you set up your servers. You can have as many instances or servers as you want. Today we're going to be using a SQL Server 2008 and a 2019. Like I said, you can have as many as you want. This button here verifies the connection, so you can, if it's green here, it's already been verified. If it's red, it's unverified. You can just click that and it'll connect and let you know how things went. The plus, if you create a new server or update an existing server, plus will save it and X will delete the server. Same thing with query, plus will create or update the query and X will delete it. You can have as many queries as you want, as many servers as you want. The only limitation is disk space. So we have one query, and this query does pretty much nothing. So I told you about how it creates a plan to execute your SQL statement. There are two ways to do this. There's an estimate where it just guesses, how long it's going to take, what resources you're going to be using, and it tries its best to give you an accurate estimate. Sometimes they're wildly off, but we'll let that go. But the thing is, the query is not executed. It's just estimated. And the other one is execute. If you want to execute it, it will give you, you'll get a lot more information actually and more accurate. But it will actually execute the statement. So if you have something going on in a table, it's really gonna work. Okay, so it's going to take this. We're going to start with 2019. It's going to take this query and give us. We'll start with estimate, I guess, and give us an estimate of what this is going to look like. This is the cracker button. This is to start the crack. There we go. Connects, and it's there. Okay, so every step of the way, these are called nodes. You can see, let's start with this one. You can see how that node is. Now, if you want to see what the node is actually executing, just let it linger, and it's nested in a loop. Spoiler alert, if you look at this query, those cross joins are going to be horrible. So this query actually takes about 43 seconds to run. Okay, so a little bit about what I did with the data and how this works. Like CPU here, it shows 100%. That isn't 100% of the CPU of the computer. What I do is I look at all the CPU values. I take the highest one and say that's 100%, even though it's probably a small fraction of your CPU's actual usage. But we're not looking at the computer. We're looking at the query, and we're looking at the different steps and how they relate to each other. So if you have, let's say your CPU usage is 1,000, and then the next node it's 500, so that'd be 50%. You'd show 50%. 250 would be 25%. 100 would be 10%, etc. But the point is, you're evaluating one step over the other, comparing the two. Now about the graphing here. Red is always 100% if it's red. And you'll notice that the second 100% is a little darker. All the reds get a little darker. All the greens get a little darker as they go down the chart here. If there's no value, like IO here, it's just a black dot. If there's a value, well, here's one, and it's less than 1%, so it's going to show up as 0%, which it does here. Number of executions shows up as 0. It'll be green. So the green says there is something there, and if there's a value, it'll chart it. But if it's below 1%, or 0%, it will just stop, or below 1%. So we can step through the process here. Nothing much going on with any of these. These look really efficient. A lot of I/O on this one. This is, it's too big for you to see. It goes across the screen. Clustered index scan. Okay, so that's an estimate. And if we wanted to go to take the same query and do 2008, we go there, crack it again, and now it's running on 2008. And completely different, of course. And that's estimates. Okay, so before we move on to execute, there is one thing I want to mention, which I forgot, is the go command that you use in Visual Studio. You use that to break up your different functions in your query. Go is not an SQL statement, and it will cause your if you use it within query or Quacker, it's going to fail. What you need to do is replace all your goes with semicolons, and it'll work just fine. Semicolon is acceptable, go is not. Okay, let's move on to execute. And we're on 2019, which is good. Let's just crack it. All right. So now what you're seeing is the different nodes again, but what you're seeing is it executing in real time. You can see the rows and elapsed time and CPU time changing. So we're actually watching this query go through the cracker. If you touch it, if you touch the list box here, it will show you how much time has elapsed, total time. You know, you can see elapsed time for each node. Nothing much going on here. We got one scan. See, now here you have one scan, but it's 100% because 1 is the highest number of scans in the whole thing. So that's going to always show up as 100%. And scans show up again and again and again. All right, let's go back up here to here. Okay. Now this, let's see, total time, what do we got? Okay, it's done now. So now it will show you the total time. This took 46 seconds to process. And then we'll continue to the final results in a minute. Now, if we would have run this on 2008, we wouldn't have gotten, the screen will go blank, but we won't get any of this information because the ability to look at a real time, look at a execution plan in real time only came about with SQL Server 2014, if I'm not mistaken. So anything after 2014, you know, you'll get this actual data, this real-time data. Before that, you won't. It doesn't affect, the query is still run, and you can still get the final results, but you will not be able to see the individual nodes as they execute. All right, so let's go on to final. And this should look familiar. There we go. And it's the same as before, exactly the same data actually as the estimate, but it is now absolute and real time. Look at that subtree cost. And nothing going on here. This looks like pretty efficient. Here we go. So when you run the cracker through your query, it automatically produces an output file. And I made this automatic because the idea is, you know, you're working through your query and you're adjusting things. It'd be nice to go back and chronologically see what each step did. And so it automatically creates these files. The file names are the name of the query, then the name of the instance. If it's an estimate, it'll say estimate, and then date and time that it happened. So let's just look at a file quick. All right, you'll notice that the nodes start here, and it's node 2. Node 1 is always the command itself, so this is essentially what's in node 1. It also shows your total runtime, so you can compare those on your different, as you modify your query. It shows everything you need. It shows the statement, shows everything that the desktop shows. It's just nice to have it, you know, somewhere where you can print it out and make notes on it. It is just a text file, so you can add whatever you want to it, you know, notes so you can remember things. And that's pretty much it for Quacker. I hope you enjoyed this, and I hope you'll consider purchasing Quacker. Thanks.